Good afternoon once again, and thanks Anirudh, for inviting me. Okay, and so in this session, let's keep this interactive. Okay, if you have any doubts, if you want to stop, feel free to do that. Okay, so the objective is for me to share and for you to learn, right? So that's really the background of this. So before I start off, let me introduce myself. Okay, my name is Govind. Okay, I come with about 2 decades of corporate experience. Okay, I'm the founder and CEO in an artificial intelligence venture. And prior to this, I worked, in the corporate world, majority of the time with HP. I have quite a bit of experience, in the Asia Pacific region, right? Singapore used to be the corporate headquarters, of Asia Pacific region for HP, right? So I'm just waiting for this Corona to get over to make a trip once again to Singapore. Okay, so and I'm also an author, right? I've written a book, come with strong experience, in the artificial intelligence and also the Six Sigma space. Okay, so this is my profile in brief. I'm going to share my experiences, my perspectives, right? So as I said, let's keep this webinar interactive, engaging, right? Let's all learn from one another. Okay, so that's really the thing. Okay, before I start off, I just want to ask a question. You're all students of the machine learning course, right, or data science course? Am I right? You're all from which discipline? If you can just uh, let me know.
So Mr. Govind, everyone here is actually from like varying backgrounds. So I think most of them over here are currently freshmore students. So they have a common first year in SAPD.
Okay, they have a common first. What kind of course they are pursuing?
So they get to choose their majors only after first year is over. So as of now, everyone just goes through a common curriculum.
Okay, so and this is the undergraduate program, right?
Yep, that's right.
Okay, okay, good. So I can relate. I know I went through your question. So the reason I'm asking is I can structure this session accordingly. Okay. So now before I get into the core contents, this is a brief introduction about my company. Okay, Seaport AI is an AI startup with a mission to simplify advanced technology. Data analytics, is our core. In fact, you might have heard the term, or you might be keep hearing the term data science. Okay, data science is used. The term is used more in the academic world. In the world of business, we use analytics. Okay, so you are trying to analyze things, and you are trying to draw some inference out of it. Okay, so that can be one of the core learnings for you. Okay, the word data science is not used uh, as much in the world of business. Okay, it's more a term used in the academic world. In fact, someone has asked this question too: what is data science? Okay, so data science, whichever way you put it, is about, can I use the data, okay, to draw meaningful inferences, right? Can I use it to predict something? Okay, and coming to this particular thing, right? Seaport AI, we are an AI startup. Core is analytics, data science. We are also into automation and blockchain. Okay, and our solutions have been deployed in multiple sectors, and we are a top 20 AI startup for 2019 as far as CIO Review Magazine is concerned. We are present, in most major geographies, right, through either our partners or our sales regions, sales organization. In fact, for Southeast Asia, we have our my co-founder Raj. He could not join. He's based out of Singapore, right, and our development office is based in India. Okay, so this is a brief about this organization. So to understand, I want to start off with what is AI, right? I want to start off from there. So can anyone tell what is AI? Can anyone tell what is AI? Am I audible? Or have I lost you?
Some things are taking place on the meeting chat.
Okay. Oh, people are replying there. Is that okay?
Yeah.
What can I see? Okay. What is that? Okay. I'm a staff from, okay. Software that learns on its own. Yeah. Yeah. What else? What else? Any other thing about AI? Come on. Let's start from the very basics. You need to open up, guys. A set of adaptable heuristics, okay? Software that makes decisions that are hopefully very appropriate, okay? Software that eats data, okay? Good, good. What else? Oh, you are giving me a Wikipedia link. Okay, I know. Okay, okay. I think a lot of interesting responses. A lot of interesting responses. Okay. So, what else? Okay, evolves through multiple generations of learning. I think very interesting examples you all provided. Okay, good. So it is actually a software. Okay, that thinks and acts like human beings. Okay, that's AI, right? And that's why the word artificial is there, and that's why the word intelligence is also there. It's a software that thinks and acts like human beings, right? And it's a rapidly growing field. You may be asking, is it thinking and acting as much as humans? Can anyone answer that question? I'm saying that it's a software that thinks and acts like humans. Is it acting and thinking as much as humans? Okay. Or maybe some action is going on in your chat. Not yet. I think it can be. Okay. What else? Not exactly the same. Okay. Okay. So you're almost there, right? So it's a software, right? That thinks. Keep that question to yourself. I'm going to answer that shortly. Okay. You all know it's a rapidly growing field. Impact is there everywhere, right? So some of the examples, it is used to predict diseases, right? It is used to predict and prevent fraud. Okay. It is used in recommendation system, digital marketing. Can anyone tell what is this recommendation system? Why don't you unmute and talk? Are you in a noisy place?
I think because many of us are work from home, right? It may not be very conducive because it's likely there are other people around as well.
Okay, okay, okay.
Yeah, so sorry.
No problems, no problems. No, I'm used to. I think ever since this work from home started, okay, I think in fact since I've been doing this for a long, long time, because we used to catch up with our counterparts in other parts of the world, right? You invariably have to work from home, if you have to cover multiple time zones, right? So there are always bound to be disturbances. I really don't have a problem. Okay. So feel free if there is any background noise, I really don't have an issue. So you can just answer and then unmute. Okay. Or you can chat. That's not an issue at all. But unfortunately, I can't see the chat and talk. Okay. Unlike Zoom. Okay. Just that I need to go out of the thing. Not exactly the same. Okay, so keep this question in a, yeah, I asked this question. What is the recommendation system? Can anyone answer this question? What is a recommendation system?
Hello,
Yes,
can you hear me?
yes, yes.
I think the recommendation system is whereby it tracks your browsing history and it gives you recommendations based on the browsing history.
Good, good.
Yeah, like it tries to predict. It's like a AI in a sense. It tries to predict what you're looking for and it gives you what you want. Like
Exactly.
the algorithms in YouTube and Google.
Correct, correct. Very good.
Yeah.
That's you bang on. Okay, so that's the recommendation system, right? So it uses your browsing history, search history, right? And then it tries to group you with people who have similar interests, right? And that's how it gives you a recommendation system, right? So what you see in Netflix and Amazon Prime, right? That's also based on recommendation system. Where else do you think a recommendation system can be applied?
I think it can also look like what kind of advertisements it shows you when you surf the internet.
Right?
Like for example, if you are say looking for computers on Shopee, for example, like when you are surfing internet, you will see more computer ads around as you surf the internet.
Yep. Yep. From an organization perspective, you're all going to be, entering the world of business soon, right? So recommendation system can also be used, let's say, in your academic thing, right? Which course you're likely to choose for your post graduation? Can I predict? That's also recommendation system, right?
Yeah, I think so. Yeah.
Right? So that's being used by organizations, right? Let's say you buy one product, what additional products can I recommend to you? Okay, so that's done by the recommendation system, right? So we also have face detection, right? I'm sure you're all using face detection even to open your mobile, right? Open, access various apps. So you see that AI is used, in a lot of areas, right? So the key point is it's already there. So we are all part of the AI era. That's what I want to say, right? And if you really see the history of artificial intelligence, it's starting from 1950, okay, with Alan Turing. How many of you know who is Alan Turing?
The father of computing.
Yeah, you can say that. What else you know about Alan Turing?
He made the Turing machine.
He made the Turing machine, yeah, the Turing test. So I think many of you know Turing test. What is Turing test?
It is basically a test to sort of identify whether something is AI or not. So essentially, it is if something mimics human behavior or human thought, then it can be considered as AI along those lines.
So whenever you have a system and say that, this system acts like a human being, if you put it through the Turing test, we can say whether the system is really AI or it's more aspirational. Okay. In fact, the Turing test has not been beaten since the 50s. Okay. Now, if you see that this technology, has been around since the 50s, why is it that everyone is talking about it, in the last few years? Has it ever occurred to you?
Because now it's much more accessible, I think.
Well, accessible, yes. What else?
I think because now like it's more advanced and we have the technology available to like apply and create and use AI. Because back then the technology wasn't that advanced, and even though the AI technology exists, like we couldn't maximize it, so it wasn't like so widely used at that time.
Can you be more specific? I understand where you're going, but can you be more specific? You're almost there.
Basically now we have more advanced computers, like basically handle AI and like machine learning software basically.
Yeah, yeah,
Nowadays, it's like a consumer facing thing, right? That people all over like interact with and know that it affects their daily lives.
right. What else?
I think also it's the amount of data that nowadays can be digitized and can be harnessed to feed into the AI
Right.
that allows it to become more advanced.
Good points. Good points. Right. See, but understand this is a key thing, right? You all need to understand this perspective. Okay. So if you see that the technology has been around for 50s, right? And Alan Turing, before I come to this, Alan Turing was a mathematician. Okay. In fact, he broke the Enigma code. Do you know what is an Enigma code?
Code used by the Germans in World War II to
Right.
transmit
Exactly.
information.
Right. So we all think, the war was won by machines and, whatnot, politicians, right? But actually, the war was won because Enigma code was broken. Before the Enigma code was broken, the Allied forces, right, the UK, and all those, France and all of them, they were losing a lot of battles because Germans were able to pass on messages as to when they are going to strike, right, to their own teams, okay, and how they are going to strike. But when they broke the Enigma code, the tables turned, right? So the sometimes we don't realize the importance of work done by a mathematician, right? So the reason why I'm saying is AI is also about numbers. We will come to that shortly. Okay. In fact, there is a beautiful movie called The Imitation Game, both in Netflix and Amazon Prime. You can go and watch. It's on Alan Turing. Okay, very good movie. So coming back to this question, right? What has happened of late? So one is the computing power has increased. What has led to the growth of computing power? Have you
Technology advancements.
right? Yeah. The key thing is GPU. Do you know what is a GPU?
Graphic processing unit.
Right. It was not there before. In fact, only in the late 90s, primarily to address the gaming industry. All right. One, and then the advent of mobile in 2000 and smartphones specifically in 2007 2008 time frame, right? That led to more data being captured. The third one is what is known as cloud. None of you mentioned that. What is cloud?
External servers that we use for consumer stuff mostly, I guess.
Not just consumer stuff, everything.
Research and
Yeah,
stuff.
today everything happens on cloud. How many of you know what is AWS? How many of you know what is AWS?
Amazon Web Services.
Right? It's Amazon Web Service. Do you know that Amazon makes more money from web services than e-commerce? As much as 80% of their profits comes from AWS. That's how big cloud is. All of you mentioned about computing power, right? Talked about data, right? That's because of mobile revolution. The other thing is internet, the cost of internet has also come down, right? That's also a key factor. And cloud, right? And all of this has accelerated the adoption of cloud. So all these technologies are giving a shoulder to AI, right? So please note that AI is basically a software, a piece of software. It can reside in a in a hardware, okay? But it's essentially a software. And though the technology has been around for a long time, it has picked up pace only in the last few years because, as you rightly said, computing power, right? Today you can buy a gaming laptop, right? Sometime back it was unaffordable. Only research institutions or people with deep pockets can buy it. Today, anyone can buy a gaming laptop, right? I know it's slightly costly, but you can buy it, right? And cloud is made accessibility a much easier thing. Do you know what is the biggest advantage with cloud? What is the biggest advantage with cloud?
It's connected through the internet.
Yeah. What else?
You don't have to pay for like, the entire like computing service that you're using, the machine.
Exactly, right? What is the key word? Flexibility. If let's say you are a startup, I don't need to buy everything on day one. I can slowly and steadily add services, right? Today my entire organization is on cloud. I don't have anything, it's only I have laptops in my premises, that's all. Everything is on cloud. Something like this was unthinkable some time back, right? So it's changed the game. And not only that, I can bring a solution to market much faster. That's another advantage, right? So I can test something much faster and at a lower cost. Someone like you, right, who is studying, you can aspire to start an organization, maybe even go on to become successful, but you need a start, right? Cloud has made that starting process a lot easier, okay, and less money consuming. You need to spend little money, but lot less than when you had to start something 20 years back, right? So please keep this perspective in mind, okay? So this is the Turing test. As I said, originally the way the Turing test was designed was if you have a system, right? Someone will ask you a question, will ask also a human respondent the same question. If the interviewer or the assessor is unable to make the distinction between whether the response is coming from a human or a system, then the system is supposed to have beaten the test. Okay, as I said, many people have been trying, people have even had games, competitions, but no one has beaten this, right? Can Siri or Alexa pass the Turing test? Probably not. We are not there yet. Okay, so another important thing that I want to highlight to all of you is what is known as strong AI and weak AI. Okay, where we are today is actually known as weak AI. All we are doing is we are solving problems by detecting patterns. Okay, and it's the dominant mode of AI today. What is called a strong AI is computers thinking at the level of human beings. We are not there yet. What you see in movies, okay, it's definitely not a reality. Many things are being attempted, okay, it's cooking in research establishments, okay, research and development organizations. It's yet to become mainstream, okay. So can anyone tell what is this solving problems by detecting patterns?
I believe it's when the AI, right, when the AI takes in data, like a history of data, and he like analyzes the patterns in the data, and then he predicts the future based on that data that he has.
Right, so what is a pattern?
Okay, maybe like if I explain from say like a digital marketing point of view, say a pattern can be like, let's say I'm looking for laptops and then I look for thumb drives. So the pattern can be like, when they group consumers together when they're interested in this thing and they're more likely to be interested into other things within that group.
Yeah, you're almost there. Anyone else want to take a shot at it?
I think it's also like they use like various parameters based on the data, and then they check on the correlation between the different data sets.
Okay, okay.
So like with this kind of, with the pattern, like if something happens, if A happens, B is likely to happen. So if A happens, then you make a guess that B will happen and you make a choice based on that.
Right, right. Okay. So what exactly is a pattern? And how is that related to AI?
A set of associations
Mm-hmm.
that a set of behavioral associations that result in the same outcome that you desire.
Mm-hmm.
And that's related to AI because AI can make decisions to bring you towards that desired outcome. So they can capture these associated patterns and try and direct behaviors or happenings toward the outcome.
Good, good. But what exactly is a pattern?
A set of actions that is repeated.
Repeated. Good. Right? It can be there even in our shirt, right? Or whatever dress you're wearing. I'm wearing a chick pattern dress, a polka pattern, right? Zigzag pattern. Pattern is the same, right? So the gentleman that you see on your screen is John McCarthy. He coined the term AI in 1957. Okay, so reason why I'm sharing this is the technology has been around for quite a while. Okay, a lot of new developments like cloud, computing power growth, and your internet speed, all of that, and of course the data, right? Huge amounts of data that is being captured. All of that have led to the acceleration of artificial intelligence, right? So coming back to the question, what is a pattern? A pattern repeats itself in a recognizable way. Okay, it's a consistent recurring characteristic that helps us to identify a phenomenon, right? And it's a consistent recurring characteristic if anyone is interested in the definition. Okay, and patterns are there in nature, right? You can see patterns. In fact, we are all able to identify patterns around us. In fact, if you like someone, that's because of familiar face, right? So there is a pattern to familiar face. There is a pattern to unfamiliar faces. There is a pattern to faces we like. And we all do that intuitively. Okay, so it's a basic human intelligence to detect patterns. It is this pattern recognition that we are going to introduce in software, and that's why it's called artificial intelligence. Okay, and that's the dominant mode today. Is it the only intelligence human beings have? No, we have other types of intelligence. Pattern recognition is a very fundamental one. Okay, that's why AI that exists today is called as weak AI, right? In fact, if a child is not able to recognize a familiar face by the end of the first year, what will the doctors probably say?
Delayed development.
Delayed development. Yeah, the doctors will say one, delayed development, probably headed for a developmental disorder also, right? Because the child is expected to differentiate between familiar and unfamiliar faces by the 6th month, right? We learn to detect patterns from 6th month onwards, right? So it is this pattern recognition that we are going to teach the computers, right? So you understand how AI is related to this, right? So it is this pattern recognition aspect that we introduce in our software, right? And that's why it's called artificial intelligence. Okay. How do you think a loan defaulter and a disease is predicted? Now that you guys have understood pattern, how do you think it is detected?
By matching like precursor patterns of phenomenon
Right.
to
Mm-hmm.
to sets of outcomes
Okay.
that match these precursor phenomenon.
Right. What else? Think how a disease is predicted, how a loan defaulter is predicted. The process is the same as you would recognize a familiar face, right? Or a face that you will like. There are some patterns, right? If you have to like a particular face,
I think you can also cross-refer to previous cases that were diagnosed with the same disease.
yeah, yeah, good, good. You're almost there. So the way it works is when you're going to predict, right? So you have what is called past data, right? Then you have current or future, right? For example, if I have to predict whether someone will get a heart disease or not, okay? So what I will do is I will collect patient's data like that person's BMI, age, sex, right, race, cholesterol, BP, sugar, right? So many data and the fact whether they had heart disease or not. I will collect this information. So what the algorithm will do is it will find the best combination, right, that can predict whether someone will get heart disease or not based on these parameters. It is like if you're going to a shop, right? Let's say to buy a shirt. Okay. What are the things that matter to you? Probably the color, the fit, design, and also price. In your mind, when you're doing selection, what are you doing? You're actually giving weightages, right? Maybe color is more important to you, right? For someone else, fit is more important. For someone else, price is more important. So you're actually juggling around different parameters by giving different weights. We do that or not? We do it intuitively, right? Because we also have characteristics. We also have parameters on which we evaluate, right? So it is the same thing that happens here in algorithm as well. I have different factors. All I need to do is find weightages. That's what the algorithm will do based on the past. It identifies the perfect weight, the optimal weightages, right? That can be applied for current or future patient data. So I can tell whether someone will get a particular disease or not. In this case, it is heart disease. Do you understand how it works?
So it's like determining your patient's risk level based on their current data.
Yes. See, when I predict, okay, I'm only giving a probability, right? What is the likelihood that someone will develop a particular disease? But the key aspect is I'm evaluating weightages. That's what the algorithm actually does. Right? So can you attempt how someone's loan defaulter, whether how will a bank or a financial institution predict whether the person who is taking the loan is a defaulter or not?
I think the data can be taken from the person's financial background
Mm-hmm.
and like family background.
Yep.
Can relate to like what's the person's income or like monthly salary. What are the person's like maybe like the relatives that are surrounding that person, the financial background of those of the family members. It could be the assets a person are holding in an investment sense, whether the person is in a business or in a financial world kind of thing.
Yep. Good. Good. So many things can be evaluated, right? So what is the
Yeah.
algorithm doing is it is studying the past. Okay. It is studying the past. It is evaluating the past records, and it is finding out the best combination, best weightages to predict whether someone will default or not. Today, both the things are already happening. Okay, both are already happening. People are predicting diseases, people are predicting loan defaulters. Okay, this is happening. Okay, at a big level, and organizations are able to take decisions also. Okay. Now, can you tell me what are the patterns in this? If let's say I have given the task to you, right?
Okay, I can predict that. Okay, basically the data is slowly increasing up, but every time it increases up, say that around July 10, when it goes up July 10, it reaches the peak and then goes back down again.
Right.
And then when it goes down to around Jan 11, it will slowly come back up around July 11. It goes to a peak and then goes down again. So it's like a repetitive up and down pattern.
Repetitive
But
up
the
and down.
chart,
Yep.
repetitive up and down pattern. But the chart, it generally goes up.
Yeah.
Yeah.
Yeah. What else?
So I can forecast if I may based on this data, right? If I may forecast after this, right, the chart is gonna go up again, maybe to reach a peak around 20, 220,000, and it's gonna drop again.
Yeah. Yeah. What if you were to tell? Yeah, I think you covered most of it, right? Any other things? Maybe something that he has left. Anyone else want to cover?
When it decreases, it will come to rest at a higher baseline than when the increase first started.
Right. What else?
So in addition to that, the cyclic peaks have been increasing as well, and have actually been increasing a lot faster than the cyclic lows. So the overall variance of this cycle is actually increasing as well.
Yeah. Good. What else?
Also think that you can actually draw like an imaginary exponential line to connect all the cyclic peaks and the cyclic like cyclic lower points, and you can connect these points to like find the what would be what would the future peaks and future lows be, and from there you can like make your predictions based on there.
Okay. Okay. So I think you covered it pretty much, right? So it is one, it's constantly increasing, number one. The other one, the key observation, I don't know whether you covered that, is that the peak is happening in the month of July and the trough is happening in the month of January every year,
That's interesting.
right? See this?
Yeah.
The peak is happening in the month of July and the trough is happening every year. What is this? Trough is happening every year in the month of January. Okay,
So it reaches the peak at the mid of the year, and then it goes to the lowest point at the start of the year.
correct. It's going up and down, but the peak is happening in July. So if you have to If I'm asking you to predict the future set of values, the key thing that you need to take into account is the peak will be in July and the trough will be in January, right?
Yeah.
Why do
Yeah.
you think this kind of forecasting is helpful in organizations?
I think it's like so useful because it allows companies to predict what will happen when it approaches this time of the year, and so they can better predict and prepare themselves for that situation. Say, for example, a stock market crash.
Yep. You gave stock market. Where else? Yep. Where else do you think this is helpful?
I think this helps with inventory management, because especially with those with cyclic supply and demand figures, this will help to sort of like predict how much storage space one would need, or whether or not they would need to call on their supply orders a bit earlier.
Right? Yep. Supply chain is a very, very good example. Any other example that you can think of? And
Maybe you say as a
yeah. Go ahead. Go ahead.
sorry, just say it, sorry.
No. Go ahead. Go ahead.
Okay, so maybe let's say you have a business that a business at a beach resort, right? And you know your business only works well when it's hot in the summer. And you know on this data, like say based on this data that people go overseas maybe during the mid of the year, July. So you know which time of the year to focus your business on. And you know that which time of the year your business won't do so well. Like that's towards the start and end of the year.
Yeah. See, in fact, the whole of business management is about managing your highs and lows, right? Let's say you run a restaurant. You know that at times, certain times of the day, there's going to be more customers, right? More walk-ins. And that applies even to, say, a hospital, right? So knowing when something will peak and something will trough, right, is very, very important aspect of the business. As someone said, it is used in supply chain planning. Let's say if I'm a restaurant, I need to buy the raw materials, right? If I'm, let's say, running a hospital, I need to have doctors. I need to have rooms. I need to buy all the materials that is expected, right?
Right.
And it is also used, okay, in what is called as sales commission, right? Many of the organizations sell through dealer network, right? You have to set targets. Companies don't sell directly, they have dealers. You have to set targets for which commissions are paid. Now, the target setting should not be too tough or too soft, right? You don't want dealers to be making money easily, right?
Like
Look,
the managing of expectations, is it?
sorry?
Are you referring to like so where you can manage the expectations of the amount of
One is,
sales that you can?
see, normally sales targets are set in such a way that, one, it is attainable at some level. Two, people need to put in effort to achieve it, right? So that, they can earn a commission, right?
So
So,
that they can strike a balance, like they
strike
can
a balance.
strike a balance.
Yes,
Yeah.
they strike, because if it is
Okay.
too easy, right, they're going to make money. That doesn't make it interesting. If it is too tough, right, they want people to lose interest after a point. So the
Yeah.
key is to find the balance, and this kind of forecasting. In fact, forecasting is one thing, right? Although people talk so much about, your autonomous cars, face recognition and all that. If there is one thing that everybody is using as of now, okay, it is forecasting. Many organizations are using this. Many new algorithms have come that have improved the accuracy of forecasting, because forecasting is like bread and butter for any organization. Your entire planning is based on this, right? Take for example your college, right? Your college, it has an administration, right? they will normally plan, we are going to take so many students next year, right? Assuming
Yeah.
the normal intake is 30. Imagine if it is going to be 45. Suddenly it increases, right? Yeah, they can say no. Fortunately, they are able to say no here, right? But what if you're an organization, you can't say no? You need to plan for it, right? For example, this COVID, right? In fact, the discussion that is happening in the academic circle is many of them are doing, the courses are conducted over online. In some places, they are not able to do. So next year, when you come to next academic year, two batches of students are going to be there. One for the current year and one from the previous years. This is already being debated in many academic circles, right? So your entire, existing infrastructure goes for a toss. And if it goes for a toss, it leads to dissatisfaction. If it leads to dissatisfaction, it leads to a drop in revenue, right? So forecasting is a very, very fundamental thing. If you are wanting to do, right, you want to apply AI, apply it in forecasting first, right? In fact, your AI, right, it can be applied in multiple fields. Go look at algorithms, go look at different scenarios and try to apply them. Can you forecast the future values, right? I will even say that, you can use this, right? You can use a variant of this, okay? And you can even try to predict what kind of marks you're going to get, right? Based on your past performance, I can predict, right?
Right.
That's also forecasting, right? So today, forecasting is a very, very essential tool, right? Used in supply chain, used in business planning, used in deciding sales commission structures, used in manpower planning, right? I need to know how many people to be hired and everything, right? What level of accuracy people expect in the world of business? What is accuracy people want?
As accurate as possible.
Give me a number.
10%.
Sorry,
Within a 10% range.
that means you 90% accuracy.
Yeah.
Okay, what else? Anyone else want to try?
I think it would depend on the application, right? Like healthcare might be different from, stocks and things like that.
Right, you
If I
tell me.
understand the question
You tell me
correctly.
if it is healthcare, how much, and if it is non-healthcare, how much.
I mean, for healthcare, probably they would want like a much higher accuracy. So
Give me a
like
number. Give me a number.
like 95% for some things, like
95 for
life-saving
healthcare, right?
procedures. Yeah.
Okay, what else?
I think it's really useful for setting a budget for certain events. Let's say I have this event, I forecast that I did this amount of budget to cater to this amount of audience or like people per se. So by forecasting, I forecast how many people will be participating in this event, and I know roughly around what budget I can set aside for this event. Otherwise, if I overlook this matter and I end up having not enough money, it'll be an issue for the business.
Yeah, you're right. You're right. See, the key is any other numbers before I give the answer. I know I'm hearing only a few people talking. Can those who have not spoken, please give your perspectives? Think, wear the hat of a business manager and think, right? An artificial intelligence expert has come up with a forecasting solution, right? And he's telling a percentage, maybe some accuracy number, and you have to give your feedback.
I just had an idea.
Yeah.
I think one way you can use this, like, can look at it in terms of politics. Say like I believe, like, I think it was months ago when our government released the annual budget plan.
Mm-hmm.
So like based on like using this idea of forecasting, they can forecast based on our population size, our economy, and so on and so forth, right? What will the budget for like this year and next year and so on and so forth,
Okay.
and like basically understand how much can we spend on like certain specific areas.
Okay.
Yeah.
Okay. Yeah. Yeah. True. Yes, the allocation happens. But what is the level of accuracy we want? Okay. The level of accuracy people expect in healthcare is more than 99.5%. Non-healthcare, others, people want an accuracy of 95%. Right? Why more than 99.5%? Because it's a matter of life and death, right?
That makes a lot of sense.
Yeah, it's a matter of life and death. You can't afford to make a mistake.
Yeah.
Okay? And why, in the case of others, 95%?
Because their life is not at risk.
Ah, see, because our organizations work on wafer thin margins,
Okay.
right? That's a given, right? Every business is operating on wafer thin margins,
Right.
right? Many organizations operate at not more than 10% margin level, right? So your accuracy can't be 50% of the margin level. So you understand, right? Why you show how much effort you need to put in.
Like it will cost more to predict more accurately or
Right.
demand.
Well, that's then people say that I can as well make a guess. No, this is how the world of business will turn around and say, this is not an academic exercise, right? Right? Yes, but don't ask for too much money, right? That's where the challenge is for today's AI, right? That is precisely the challenge everyone is facing. Yeah, if I spend more money, maybe I have a better solution, right? But can you manage, right? So that's the challenge, right? The reason I'm spending time on forecasting is I know you may be hearing a lot of technologies, but organizations today are still, focused on the forecasting piece. Even today, many organizations miss this, right? Millions of dollars are lost because forecasting cannot happen. Forecasting cannot happen properly, right? Yes,
May I ask, like, for example,
sure.
like what of like companies losing money because they can't forecast properly?
Yeah, that is happening. Yes, because you rework, everything that happens, right? All the inefficiencies. You need to hire,
Right.
Sorry, go ahead.
Okay. Okay, like deficiencies, like specifically.
See, for example, let's say
Okay.
you're running a restaurant, right?
Okay.
You,
Yeah.
you don't plan, right? You don't plan well. You're not hired sufficient number of people to man the restaurant, right? You have to
Right.
you have to turn them away, right?
You gotta forecast your resources and know what you need
Yeah,
to sustain your
it's
business.
tied to everything, right?
Okay, that makes a lot of sense. Yeah.
This is tied to everything in the business, right? Because unless I know how much I'm going to sell, how will I plan? It is to the last mile, right? I need to plan.
Yeah.
If let's say you're running, let's say you're selling, for example, automobiles, right?
Okay.
I
Yeah.
need to know how many repairs are going to happen, right?
Yep.
because I need to replace so many spare parts. What if I don't have spare parts? People will wait for repairs. That will lead to dissatisfaction, right? So this cuts across the length and breadth of any organization.
Basically, it makes things like even more efficient.
Yes, the key thing that we are talking is what is known as forecasting at scale. You're not talking about doing a proof of concept. You're talking about running a system that can run at scale. Imagine you're running $1 billion organization, right? The complexities due to scale are very high. Can your forecasting system take care of that? Right? And that is where the full stack data scientist comes into picture, right? So what is that? You have the algorithm, right? That is running.
Okay.
And then you need your data. You need to worry about how the data is procured and managed. Today, how many of you know what is big data? You've not heard the term big data?
It's just like massive amounts of, I'm not very familiar, but it's just like massive amounts of data like collected by like those, you know, big companies like Google and stuff about customers.
Right. See, big data is about, let's say you have student records, right? You are part of an educational institution. Like you will have a student number, student name, right? Maybe your father's name, right? Which class you are studying and all that. How am I storing this? I am storing this as rows and columns, no? This is the traditional database model.
Like an Excel spreadsheet.
Like an Excel
Right?
spreadsheet, yes, exactly.
Yeah.
That's also an Excel is also a database. But if I have an image, your photo, how will I store it? Where will I store it?
It's an image file.
As an image file, right? And you have video, someone is recording the video, right? If you want
Yeah.
to if you want to search something in the video, how will you do it? Right? So all these
Yeah.
things, right? It's one, the way the data is stored, the type of data itself, right? The speed with which I access the data. All those things are part of what is known as big data. The traditional way of handling data cannot handle the new forms of data like images, videos, and MP3s, audio files basically. I have audio, video, and images. And why these things have increased? It is because of the mobile revolution. Right? So if I use the traditional way of handling data, I can't store my images, videos, and audio files in the form of rows and columns. I need a different framework, and that is known as big data framework. If I don't, one of the reasons accuracy goes for a toss is you don't have sufficient data. All the dimensions of data are not there. That is why your accuracy goes for a toss. So if you have to improve your accuracy, you need to increase the data size. You need to identify different types of data, and that involves database management, big data, right? So if you are a full stack data scientist or a full stack AI ML engineer, it's not only about algorithm, you also need to know how the data will be procured, how the data will be processed, where the data will be stored. You may not do all of that, but you need to manage it, right? And this data could be sitting in cloud. So how are you going to procure the data? Right? So can you see why the knowledge of database is essential for you? Today the world is moving, today Amazon Web Service is offering a platform, okay, known as SageMaker. I can store data, I can process data, I can run algorithms. Everything is happening within this environment. So I need to know, right? I need to know how data is processed. I need to know how algorithms are run. Because what is my objective? My objective is higher forecast accuracy, higher accuracy in my model. Because even if it is not a forecasting, you are predicting something else. It's about prediction, and when you have prediction, it's about forecast accuracy. Right? So if you want to become a successful data scientist or whatever, right? Machine learning engineer, you must not only know the algorithmic part of it, right? Must also know about big data. In fact, in my opinion, big data and the algorithms are like two sides of the same coin. Okay? Any questions on this? Any questions? Any observations?
I have a question.
Okay.
So let's say you have insufficient data in a certain data set that you're trying to work on, right? Would it be wise to use your own forecasting methods to produce even more data by predicting the trends, and then basically like sharpening the data in your through the AI that you made to basically complete the data set you're trying to achieve?
Yes. Yeah.
Make
See,
sense?
sorry, what is the last part?
No, nothing. I was just asking if it makes sense.
Yes, definitely, definitely. See, our objective is what, you want higher accuracy. That's the core thing. Whatever you're doing, your accuracy is the most important thing. How can you improve accuracy? One, you need to ensure that all dimensions of data are there in your data set. For example, let's say I talked about developing, prediction model for heart disease, right? If, for example, I don't include race or nationality, how successful will that model be?
Not very successful
Why?
because you didn't take into account the risk and the other factors that you mentioned.
Right, because race is the most important factor. As a matter of fact, okay, South Asians are more susceptible to heart disease.
It does
Okay.
seem that sometimes correlation may be mistaken for causation.
Possibly, right? That is also there. That is also there, and you can have outliers also. See, there could be a lot of factors. So you need to study all of them. Two, how you're going to collect data for all of them. Yes, I may conclude that race is an important factor. Yes, but how am I going to collect race information? It may not be easily available. Then my whole model suffers, right? Right? And let's say if the data is in cloud and I don't know cloud technologies, still it is not helpful.
So this is where big data comes in, so you can better manage cloud data,
Yes, yes,
and you can use your algorithms to forecast the even bigger data that you can manage
yes. So
to
what
get a
I'm
better accuracy.
right. So the idea is it's not only about algorithms, it's about how you're going to procure the data, how you're going to process the data. When I say procure, get, because it is stored somewhere, right? Okay. Even if it is not a, let's say, big data, I can still use cloud. Please note, big data comes only if there is audio, video, and images. If the data is stored in the form of rows and columns, I don't need big data. I can still use cloud. Okay. Right? Are you getting where the full stack view comes in? Because it's not only that, you can't say that I'm good in, if you get me the data, I will process it. Today, many people say that. Right? That's not acceptable, right? Because in fact, in many data science projects, 80% of the time goes in data collection, data preparation. Only 20% of the time for algorithms. So you can imagine how important the data aspect of the full stack is. Full stack means, I consider the back end, front end, everything. Clear? So the other piece that I wanted to cover is AI is the headliner, right? But the actual technology is machine learning. Okay. And a subset of that is known as deep learning.
Okay.
Right? AI is the headliner. That's what we keep hearing. Right? That's what everybody says. It's an AI, right? I'm doing AI course, right? I have an AI solution. But what exactly is an AI solution? If you dig deeper, it'll either be a machine learning solution or a deep learning solution. Any of you know the difference between ML and deep learning?
No, not really.
Not
Not
really.
many.
Okay. Normally, deep learning is an advanced form of machine learning. Okay. Deep learning is an advanced form of machine learning used primarily when it comes to images, audio files, video files, and text, predicting text information, like chatbots. So that is where deep learning, the forecasting model that we are talking about, machine learning itself can solve the problem. Right? So deep learning is more advanced. That is used, facial recognition, driverless cars, right? Those things depend on deep learning. So do you know what is machine learning? How many of you know what is machine learning? Do you know what are the different types of machine learning? Any of you know? Okay, let me bring that up. Give me a minute. So I think this should be an interesting one. Okay. So machine learning, there are three types of machine learning, right? One is supervised, unsupervised, and reinforcement. What is supervised learning? Okay. In this, I'm feeding an apple. Okay. And I'm telling If something looks like this, it's an apple. If I feed a pineapple, what will the algorithm say? I'm feeding a pineapple.
It depends on how it recognizes an apple, right? If like
I'm saying this is what I have fed. What will it say as an output?
if it only knows if it's, I mean,
No, not if no. This is what I have fed. You tell me what will the model say if I feed a pineapple?
it will say it's not an apple.
Right. Very good. Why?
It doesn't recognize the image file.
It does not know anything other than an apple.
Yeah.
Right? If I feed this image, what will it say? I know there is some blue thing here. You can ignore that.
Sorry, can you repeat your question?
I said if I feed this image, what will the model say?
It's an apple.
It's an apple. Okay.
I think it may not actually show this as an apple because it's actually flipped compared to what has been given before.
It will not. It's not. It may not. It will not. You're right. It is flipped to the right. Here it is flipped to the right, the green one. This is how the model will work. Okay, so this is known as supervised learning because I give a reference. In unsupervised, this reference is not there. So all that I do is I try to group. I try to group my input into similar things. If I feed a pineapple, it will come here separately. If I feed a grape, it will come here separately. These all will be shown as clusters. Okay, that's known as unsupervised. And reinforcement is it learns from mistakes. First, it will say it's a mango, or it may say something junk. You say no, it's an apple. So it kind of learns. So there is a learning involved in each of this. That is why the word machine learning. One, it looks for patterns. Remember what I said. It goes to find the perfect weights. Right? The relative importance of its parameters. And based on that, it will determine. So this is how the machine learning actually works. This is how the algorithm works. And as I said, for all of this, I need to have a good backend, right? A good database structure in place. Because my input depends on the output, right? If my input is junk, my output will be junk.
Yeah, it does.
Right? So good. So that's what I wanted to cover. So you guys have any questions? We can use the rest of the time, to ask me questions.
How would a machine learning model be unsupervised?
See, machine learning model here, it is only trying to group based on similar characteristics. Here, there is also grouping, but the grouping it is with respect to what is known as a label or a particular reference.
Yeah.
So it is only all it will do is it will group things together.
In a sense, it tries to identify which are the objects, the images that are similar.
Yes, you're right.
Group them together.
Yeah.
Okay, can.
Yes. Any other questions?
Just out of curiosity, in supervised learning, how would the model determine what exactly is an apple? Does it like would it go like so to say like pixel for pixel?
You're right,
Just
actually. Yes, it actually, that's a good question. Okay. We said,
because yeah.
yeah, sorry, go ahead, go ahead.
Oh, because like I was just wondering if it was maybe some other kind of thing like minimum size or like between these two sizes, then it won't be so inflexible,
See,
possibly.
we are telling AI, is the headliner, machine learning is the actual technology, right? So here the patterns are recognized, right? It looks for patterns. And how are patterns recognized? By analyzing the characteristics of patterns, right? Like shape, color, height, this protrusion, they are all characteristics. And how are characteristics represented? They are represented in the form of numbers. So ML is actually a study of numbers. So color will be represented in the form of pixel.
Mm. Oh, okay, but yeah, I just imagine that I assume that there are in fact like ways to have supervised learning that is less and less, uh, less and less, inflexible, so to say. So you instead of having just like image files, yeah, and you recognize it bit for bit, right? Like you would have like some kind of thing that says, oh, if it's above a certain size, then these are apples. If it's,
No. Here it is looking for multiple characteristics, right? It is based on what I feed. Actually speaking, if I feed, I didn't ask this question, okay? If I feed this image,
mm,
it will still say not an apple. We know that this is an apple, but the computer doesn't know. Right?
how do you fix this then as you go along?
That's because, as I said, we are in weak AI.
Okay.
We are trying to move towards strong AI, right? In fact, in weak AI, it's operating only at about 10% of human potential. Even if you can bring it to 30-40%, this thing can be fixed, no?
Oh, okay. Also, the issue is that there is not yet a way to do this. So.
There's not yet a way as of now.
Okay. Thanks.
All that we are doing is we are doing pattern recognition. That's all. You're not doing anything else.
Is this where deep learning comes into the picture?
Sorry, picture what?
Deep learning. Is
Yes,
this where deep
right.
learning? Yeah.
Deep learning is about images, but this concept can be used to explain both. I took an image because it's easier to understand. The concept is the same. And deep learning, anyway, is a subset of machine learning only.
Okay.
Any other questions?
Hello.
Yes,
Hi. Sorry, can I ask a question that is more related towards like the industry?
please.
Yeah. So, I was wondering like what are the challenges that data scientists would face, because I have read previously that at times data scientists like they like when they enter the industry, like their job scope is not just like analyzing data, but it's more of like a software engineer plus that kind of thing.
You're right. You're actually right. Let me answer this. That's an interesting question. I'll open this. I can draw a Venn diagram. Actually speaking, where is ML or AI, right? I will draw 3 circles. One is math, the other is programming, third is domain knowledge. So your machine learning is actually at the intersection of all 3. So you need to know the domain, right? So you know what characteristics to pick. You need to know math so you can develop the algorithm, and you need to know the programming so that you can do it. So you're right. A data scientist's job is very complex, right?
So by that like same train going through the same train of thought, right? Would you say that like data scientists as a job is like kind of like becoming sort of redundant because it's getting like absorbed into
No,
what's
no,
expected
no,
method?
no, not by any chance I'll say it's getting redundant. Okay, it is just that others are trying to enter because programming is a very very important aspect. Software industry is kind of leading the data science revolution because programming is because I can hire a math guy, I can hire a domain guy, right? But programming, the IT piece, right, both the hardware and software, is a very very important piece. So software engineers are becoming data scientists, right?
Okay.
So if you want to be a data scientist, you must know the programming piece and you must know the math piece. Domain knowledge you can pick up over time.
So may I know what you mean by domain knowledge actually?
See, for example, remember I gave the example of healthcare, right? For predicting heart disease, I picked up some 7 or 8 parameters. So I must know the domain, right? The healthcare. I must know about heart diseases, right? Before I
Yeah.
can decide which parameters to pick up.
So it's like knowledge specific to that particular industry.
Exactly, exactly.
Thank you.
Yep. Any other questions? Okay, if there aren't any questions, I'll hand it over to Anirudh.
Sorry. Maybe one last question if possible.
Yeah.
So I understand that you are currently like the founder of like your company, and I mean you're CEO of a company. So I was like wondering um, whether you are still heavily involved in the programming aspects, or is it becoming like very like managerial, administrative kind of thing?
See, it is more managerial, but being a startup, I'm more hands-on. Okay. But I'm involved in the architecting because we have a product. We have a product, SeaportAI, we have a product for risk management, that is to identify fraud. How can you identify fraud proactively, right? So that's where the full stack comes in, right? So initially I architected the solution, but once it is there, that is the initial phase. Then it's about business development. It's more business and managerial.
Well, but when you say that you architected the solution, it means that you were the one that like played an integral role in like even creating the algorithm.
Not, I will say I oversaw the whole thing, right? I had a team who built the algorithm, but I have domain knowledge there, so I gave the perspectives, right? Deciding the characteristics. So I know programming also, or rather algorithms, right? So I have played a part in choosing which algorithm, is better in this scenario, right? So those kind of discussions I have led. Because the reason I'm saying is in a startup, especially, we are about 3.5 years old, right? Uh, Compared to a large organization, in a large organization, the roles are compartmentalized. Unless you're very lucky or you grow higher fast, you don't get to see the complete picture in a large organization. In a startup, you get to see the complete view very early. In fact, if you ask me, right, I always suggest let your first job be with a startup. Because I started my career with a startup, right? Then I went to HP, a bigger organization. Because in a smaller organization, you get to see the complete view.
Yeah.
That view is just not possible in a large organization.
That's true.
Yeah. So it's because of the startup nature that I became more hands-on.
So even in your like currently you're still like heavily or like you're still involved in like
Right now, no. Right now, no. In the first
oh,
year of operations, I was, right? When we were architecting, when we were developing the product, I was closely involved. Right now, I'm not.
okay. Thank you.
Sure. That was a good question. Okay. Yep. Any other questions? Okay. Anirudh, back to you.
Sure. So thank you so much, Mr. Govind, for conducting the workshop. I'm sure everyone here learned something new and gained more insights into the AI industry as a whole. So we would like to thank everyone for coming, for attending this workshop. Hope everyone enjoyed it. I certainly did. It was very eye-opening as well. And yeah, so thank you all very much.
Yep. Thank you. And
Thank you
best
for
of
your
luck
time.
to your future.
Okay.
Thank you so
Thank
much.
you.
Thank you so much.
Bye bye.
Bye.